Hello and welcome to our first online video. Thank you for joining me. I'm Mr. Cockerell. Good to see you all. I can't wait to see you all in class tomorrow. So today we will be talking about one of my favourite topics ever. As you know, I am a chemistry teacher. I have studied chemistry and I absolutely love it. So today we are going to talk about atoms. But what exactly are they? Atoms are the building blocks of life. This means that they make up everything around us. They are combined within the periodic table. It's the most amazing thing, which really shows where each atom sits in relation to the others. And this is all sorted according to their properties. So these properties are caused by the arrangement of their subatomic particles. And that's what we're going to learn about today. So subatomic particles. So sub means below, and atomic, so below the atom, or within the atom in this case. We have the three subatomic particles, protons, which have a positive charge, so we denote it as a plus. Then we have neutrons, which are a neutral charge, so no charge, so we denote it as an N. And then electrons, which we give a negative charge to, we denote it as a little minus sign. So where do these actually sit around the atom? So we have this theory about how atoms look, and within this, we have a nucleus surrounded by electron clouds. Now, some of this has been supported through different research, etc., but this is the model we generally go with. So within this nucleus, the center bit here, we have two different things. We have the plus, which are the protons, and we have N, which are the neutrons. So that is what makes up the mass of our actual atom. Because around the outside, flying around super duper quick, we have electrons. These electrons sit in what we call shells, which is just where we're most likely to find an atom. But these electrons, because they're moving so fast, it's really difficult to measure their mass. And so as a result of this, the mass that we see on our periodic table, as we're going to look at in a second, is only the mass of that nucleus. So the mass of the protons and neutrons combined. So let's actually have a look at the periodic table and some of the elements on it. And so from looking at this, we have our atom, Be. This stands for beryllium. Beryllium is an amazing metal and is used in a lot of things actually. So this number at the top here, the number 4, this depicts the number of protons within the actual atom. So this number of protons, we said was P, so there's 4 P plus charges, and then we have this number 9.0122 down bottom. This depicts the mass of the atom. So remember previously we said that the mass is only what's in the actual nucleus, so the protons and the neutrons. So from this, our number of neutrons equals to the mass minus our protons. So 9 minus 4. So that means there's approximately 5 neutrons in our actual atom here. Now, you might be asking, how do we calculate the number of electrons, Mr. Cockerell? What do we do? Because this is a neutral atom, so it's not charged, and we know this because the periodic table always depicts neutral atoms. Out in the real world, things will rarely be neutral, and when I say neutral, all I'm meaning is that it has the same number of protons as it does electrons. Because out in nature, when atoms bond, which we're going to learn about in a couple of lessons, the number of electrons kind of changes because they move around. So that is how we find the number of protons, neutrons, electrons within this atom. For our next one, we're going to look at chlorine, Cl. So this number at the top, remember, we call this the atomic number, depicts the number of protons. So there's 17 protons. Then we have a mass of 35.45. This depicts our mass. So if we go 35 minus 17, we get 18. We get 18 neutrons within this actual atom. Now, you might be thinking that this is 35.45, sir, so why are you rounding? Well, this is because we actually have different numbers of neutrons within atoms out in nature. So this 35.45 averages all of those. So sometimes, or about half the time in this case, we have atoms with 18 neutrons for chlorine, and then just over half the time, we have the same amount with 19 neutrons. Cool? So protons 17, neutrons 18 or 19, and then our number of electrons is 17 once again because it is a stable, uncharged atom. So guys, thank you very much for listening, and I'm really excited. Hopefully you enjoyed this flipped learning environment. It provides a lot more time for us in class so that we can spend more time doing fun activities, experiments, things that hopefully you guys will enjoy a lot more. So, before class, all I want you to do is come and show me N for nitrogen on the periodic table, how many protons, neutrons, and electrons it has. Thank you for listening. See you in class. Bye.
I just blew my mind.